Okay, let's continue where we left off. Let's do x tan x and x log x, I think. Okay, we have restricted domains. That's helpful. Okay. So, yeah, all right. I mean, the first one ain't so bad. Because I think it's a quadratic shape. It's going to be well, actually, it has an asymptote, you see, tan at pi over 2. So at pi over 2 and pi minus pi over 2 minus pi, you've got an asymptote here and here. And this is an even function. So it's going to be like this. It's a root at 0, at pi at 0, and at minus pi. So yeah, I think it looks like this. And then x log x, all right. But only in the positive. You can't have 0. Ooh, what's happening at 0? It's not defined at 0, but I think it's an asymptote. And when you have 1, it's a root. So I think we have a graph. It's going like this, basically. Yeah, I think so. Let's check it out. X tan x. Yeah, that's basically what I drew. And then x log x. Yeah. Oh. Okay. I jumped the gun a bit on that one. All right. I just jumped the gun a little bit. This divergence to minus infinity doesn't happen quick enough to cancel out the x. So it does have a minimum point. So let's calculate it. The derivative is log x, product rule, plus 1 equals 0. So that means log x equals minus 1. So that means x equals e to the minus 1, which is about 0.2. So e to the minus 1. So that's, and if we calculate the second derivative, we get 1 over x. So that's a positive, which makes it a minimum. So it's a minimum here. And that's a root. And when x is tending towards 0, x log x will tend towards 0 as well. So it must be going like this, but it's not defined here. How can we know this? We did limits earlier, but didn't we in the book? But we didn't do the special rules that help us calculate it. So you would just have to figure it out by putting in small values of x at this point in the book, I think. Yeah, okay, so that's correct, and that's correct then. Yeah. Okay, and let's have a look at x squared sine x then. X squared sine x. Okay, so that's 2 pi minus pi minus 2 pi. This is odd. Sine of 0 is 0, and sine of pi is 0, and of 2 pi as well. So there's roots here, and the x squared is amplifying it. So it's like okay. No, that's not right. That's not right at all. Okay, let's try this again. Okay. Up a little bit. Down. No. Up a little bit. Down more. And up a lot more. Okay, let's try and make it odd. Okay, let's try and see how well I did. X squared sine x. Bum 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 bum. So let me just. Yep. You know, that ain't too bad. That ain't too bad. For a freehand sketch. So basically, the sine x is the usual situation, and the x squared amplifies it as you move out. So it's like the amplitude is growing quad power 2. Yeah, okay, that's all right. And then do we okay, now we're into something different. So I think we'll leave these for tomorrow and then get this exercise finished tomorrow. It's a short video for today. Yeah, that makes sense to separate it.